Hey everyone, welcome to Devs in the Shed, next episode. So I'm glad everyone could join us on the stream today. You've got myself, Matthew Coles, a principal TAM at AWS based in Melbourne. You can hear it's super rainy in the background today, so hopefully that's not going to distract the viewers too much. We've got Paul Kukel, who's also based in Melbourne, and he's joining from his shed. Paul is a solution architect at AWS and one of our absolute aces. And then today, I'm very excited about this, but Jason is basically the guru that we go to for literally everything to do with containers. So he's visited many of our customers. He's trained us on everything that we know, re Docker and Kubernetes and ECS and all that great stuff. Jason, did you want to introduce yourself to everyone?
Sure. I've been a solutions architect at AWS for a number of years, and my focus area has kind of always been containers. And late last year, I took the role as the first specialist SA for containers for Australia and New Zealand. So this is kind of my wheelhouse. Unfortunately, unlike Matt and Paul, I'm not cool enough to have a shed. I'm in the inner city where I don't even have a yard. And to be honest, I'm probably a little more ops than dev, and ops in the spare bedroom doesn't have quite the same ring to it as devs in the shed. But I'm happy that they looked past that and are going to invite me along to show you some neat things you can do these days with ECS Anywhere.
Yeah, no, we're more than happy to have you on the show, and I absolutely understand. I moved 2 or 3 years ago to the outskirts of the city. Got a bit of a bigger property, but I was in a small apartment back in the city, and it's a completely different lifestyle. It's still really enjoyable. One day you might give in and live in the countryside with us. We can only hope, but we'll see. Before we get stuck into it, though, like we do have quite a few things that I kind of wanted to cover in the What's New section that we do at the front. There's been a couple of really exciting things, and I might hand over to you, Paul, to kind of cover the first half of them if you can. And you might just want to come off of mute.
Sure, thanks, Matt. I'm sure we're also used to getting off mute all the time. Look, I've been using AWS for quite a long time, but one of the core services, and there's maybe some conjecture around whether it's SQS or S3 has been the first service, but SQS is now 15 years old, and like this is one of the services that like so many applications are taking advantage of this. Being able to queue up messages and not having to deploy some sort of infrastructure to manage it yourself is like one of the core reasons that SQS has been so widely adopted and so widely used. Provides so much flexibility to building those distributed applications where you don't need something to be a synchronous operation. You can we're taking advantage of asynchronous operations. And so yeah, this week was our, Jeff Barr did a specific post about it, but celebrating 15 years of its being in operation. And so there's a number of specific like announcements that have happened over that time. So there's a launch that's come out. Then they introduced it, through different regions, put in place a larger free tier that lets you go ahead and even build your personal applications. And not having to worry too much about the expenditure going too high. In 2013, we saw support for payloads up to 256K. So prior to that, it was a lot smaller, and also a price reduction at that point in time. But in 2015, there was introduction for extended payloads, and those payloads were up to 2 gig. Now you might, this is something that you might think like how. And why would you have like messages that are being up to 2 gig in size? And
I did a couple of weeks ago until you told me, Paul. You've done a ton of work in this area lately.
Yeah. And so when you're building modern applications, we think about building things from the ground up. We probably don't think about sending like large message sizes. You want to keep them small, but we also have to remember that we deal with so many different customers. So they can be greenfields building something brand new, the small startup in your in your backyard. But all the way up to like these really large enterprise customers that are going through a transition. They want to modernize and they want to take advantage of the cloud where they can, but they have some constraints. So some of their backend services are like really monolithic by nature, hard to change. but they need to send really large messages. So in 2015, there was the extended payloads library. And we're probably going to go ahead and dive deep into that another time, but I specifically wanted to call that one out. And in 2016, there was FIFO queues as well. So that means, we can have order with our queue. And those are probably the big pieces that have come out of that. So I thought that was worth a mention this week.
I actually think next week, just before you move on though, I think next week was when we'd lined up to spend some time looking at the extended sizes for SQS messages. But I wanted to kind of re-emphasize, without SQS and S3, we might not have ever had a cloud, right? In reality, AWS started cloud back in the day. We were selling off excess capacity. Some of the services that we'd used for Amazon.com that allowed us to scale and other people wanted to use. And without the success of SQS and without the success of S3, we might have never actually ended up creating AWS as a total, right? So 15 years is actually a huge landmark, and it's not just what the services released in the 15 years. It's the fact that this all kind of actually, was part of the reason as to why we have cloud now at the scale that it is. Anyone, I guess, in the chat, any experiences with SQS that you'd like to spell out about? Maybe we need a couple of birthday notes. I was going to wear a hat for the announcement, but I don't have kids, so I couldn't find any party hats. I thought I might have had a couple left over from my sister's kid's birthday. But let us know your experiences in the chat of using SQS. Little celebrations that you want to speak up, and we'll put some online on the stream maybe and talk about a little. But whilst you're writing back in the comments, I'll let you continue, Paul, because I know this is a really great feature as well.
Yeah, I would say that I don't have a customer that is not using SQS in some way, shape, or form. Somewhere they're using it. So yeah, it's everywhere. But one of the other things that I want to call out, and not specifically because it's a really amazing change or a really great, fantastic announcement, was the update to the NoSQL Workbench. And so the NoSQL Workbench for DynamoDB, but not just for DynamoDB, is a tool that enables you to visually look at how your DynamoDB structures, keys, and schema are looking. What I'll do quickly is just to show what that looks like, because there will be people that might not be aware of how that looks. So I do have that set up. I'll share my screen quickly. So we're not going to dive deep into it, but I thought it was worth at least just showing. So this is a desktop client that's downloadable for all the platforms that Linux, Windows, and Mac OS, but enables you to connect to your DynamoDB instance, whether that be in the cloud or something you're running locally with, like local stack, or setting up DynamoDB locally and being able to look at and see how you're modeling your data, but also to be able to look at the data within the database rather than going to the console. So if you're working in some sort of location where you don't have direct console access and you want a visual representation because you're trying to work out how to stitch together some of your data for a front end or an API, the NoSQL Workbench is something that's really handy to be able to go ahead and visualize how you're structuring your schemas, what the keys will look like, what the sample data is supposed to look like. Here's a specific data model, but you can look at the global secondary indexes, see how they look. I'll go back to you, sorry. But you can see, you can get a good visual representation of what you're writing programmatically. And that could be really handy if you're taking a team through some sort of design decision or workflow or something like that. So just to call out to that specific tool. But also, this is not just for DynamoDB; it's also for Amazon key spaces as well. So you can work with Amazon key spaces as well. So I thought I'd just call that out as not necessarily a groundbreaking announcement, but just to let our viewers know that there are so many of these side tools that accompany our services that I thought it was worth calling out and mentioning. Back to you, Matt, with your sections of the week, your news stories.
Yeah, I'll share a couple of other things. I am going to zap through them though, because we've got Jason here, right? And I'm actually quite excited to see ECS stretch from cloud to his Ubuntu or Windows laptop. So I'll try and make my stuff really, really quick. The first thing that I thought was really cool, we talked about it a couple of weeks ago, but AWS Step Functions Workflow Studio, they had the official announcement last week that it's now available as a low-code visual tool. So it allows you to build state machines and workflows. I'll scroll down to the diagram just to kind of highlight how cool this is. But you can see, like, you can structure up a Lambda that might do something, and then you have a choice of your state, and you build all this out visually. You can go into the code and edit the Lambda itself, but you've kind of got these extra steps that you can add in, determine workflow based on particular events that fire off. And you might have, a rule that fires off into Dynamo and then like updates tables and then sends some emails and then goes to success. But on the other hand, on the other side of things, if there's a fail, you can have an alternate workflow as well. So being able to set this up quite easily is going to make serverless a bit more accessible for people. So I'm quite excited about that. The other thing that I was going to race through, and I know DevOps Guru has been out since reInvent last year, but DevOps Guru is like one of my favorite services in AWS. So DevOps Guru has now got a quick setup that allows you to scale it out across your organization really, really quickly. The thing that I love about DevOps Guru is basically you run your workload for a couple of hours, a couple of weeks. You get a sense of what that workload looks like, working day to day and in the good state. And then machine learning is going to basically detect the variations to that. And you're going to be able to set up alerting, hey, it looks like throttling happening here. It looks like there's a large level of increase in these particular services. DevOps Guru is going to give you that visibility, and then you can dive into that second layer of observability and go like, hey, actually, this thing looks like it shouldn't have happened. This particular alert, let's look into X-ray and see if we can determine why that's happened. And then we can dig deeper into CloudWatch logs and all of that. So really, I guess from a TAM perspective, it helps customers recognize issues faster and get to troubleshooting and root cause quite a bit quicker. So big fan of the service. So I said I'll be quick, so I'll end it there. I guess, Jason, what have you got in mind for us today? Let's spin it on you. What are we looking at? ECS Anywhere, right?
Sure. Just 1 second. Let me say I want to share that screen.
And it does look like in the chat, I can see a couple of people. I'm just going to add your screen into the share, into the session. But I can see a couple of people seem to think that we're also double booked for training. I'll have a look into that in the background. So give me 2 minutes to work out what's happening there.
Okay.
But anyone that's joined for the Devs in the Shed stream, let us know if you've used ECS before, if you've looked at ECS Anywhere, if you've done something crazy like what Jason's going to show. And I'll hand over to you, Jason, to kind of run through what you're looking at.
Sure. So when ECS Anywhere was announced, one of our developer advocates did the thing that I was kind of initially thinking ECS Anywhere would be neat to kind of do, as far as a demo, which is getting it run on Raspberry Pis. And so this has been done. We've got a blog post where kind of there's a demonstration of not just like one Raspberry Pi, but a whole cluster of Raspberry Pis, and having ECS manage this for you. So because that's already been done, and I had like a bunch of Raspberry Pis in a shopping cart, I almost clicked the purchase button to do something similar. And then I got to thinking, my laptop is really well spec'd. So this one that you're seeing at the moment, obviously I've got both a PC and a Mac laptop. The PC laptop in particular has 8 cores and 32 gig of RAM. And it was basically like, I'm sure that a lot of developers out there have reasonably well spec'd machines. At least a good proportion of them might have it. And what might be more interesting than running it on a comparatively low-powered, low-memory Raspberry Pi would be, can I get the cloud to deploy containers to my laptop rather than my laptop deploying containers to the cloud? Kind of flip the whole thing on its head and get a bit more use out of the computing resources that you might have with your high-end PC or Mac. So I started down that process, and one of the other things that I've done a bit in the past is Docker and Docker. And so I kind of put the two together and made it so that you can actually join a container to ECS Anywhere, and then within that container, Docker and Docker, it can schedule tasks on your laptop. So basically, the requirements for ECS Anywhere are just that it has to be Linux, it has to have systemd, and it has to have Docker. And so I started with our Amazon Linux 2, Docker base image. I basically then installed systemd into that base image, and then
Jason,
cleared
would you
out.
be able to just zoom in a little bit more? It's a little bit hard to see.
Sure.
Maybe just zoom in on the browser. Yeah, awesome. Thank you.
No worries. Yep, good call. Thanks for that. So basically, I started from Amazon Linux and installed systemd, but then removed all the systemd stuff other than kind of what's coming with the requirements for ECS Anywhere. And I also installed Docker to do the Docker in Docker. So this Docker file and the instructions, you can see here, I've got a Git repo called ECS Anywhere Docker in Docker with this Docker file, and then step-by-step instructions on how to do this thing. And so a couple other details to kind of make this, give you a bit more context before I show you this demo. One of the nice things, I really enjoy macOS in addition to Windows, but Windows has one feature that's come along, which is really helpful for a variety of reasons, called WSL, or Windows Services for Linux. And the second version of this, WSL2, does something quite neat. So if you go to, for example, the Docker resources tab on a machine that you've set up with WSL2, you notice I don't have to specify a CPU or memory amount. And so what WSL2 is doing is basically, as processes launch in the Linux VM where your containers are running, it automatically grows and shrinks the VM as required. And so if you have a process that it could take all of the system's memory, and then you stop that process and it frees it all back up again. So it's quite nice as far as managing your resources on Windows now. You basically just have all of the laptop's resources available kind of to the containers in a way that, it only makes it available to the container if I'm not using it on the host. And I've just found this to be a quite good experience for doing Docker these days. And it happens to be that I've got way more memory in my PC than I do on my Mac. So that's why I'm demoing it on this side of things for you today. So let me, is this text big enough? Do you want me to make it slightly bigger?
Yeah, it's big enough. I was just going to call out, we've shared the repo that Jason had up in the chat. So have a look at that. I had a look into the schedule. I couldn't see what the other event was for people that came for AWS training. I checked the other AWS channel that we've got, and I couldn't see anything on either. So if you can give me some details, I can see what's happening. While I was doing that, though, I might have missed it, Jason. But we've got Docker on our local PCs to basically work locally in a containerized environment. We then send it off to ECS or EKS or Kubernetes or whatever in the cloud to be hosted. But why would anyone want to send ECS to anywhere, including running back on their local machine? So
one of the reasons why people have chosen Kubernetes is that they can run Kubernetes on their laptop and in the cloud. And it's because you make, in the case of Kubernetes, a pod spec, in the case of ECS, a task definition, where you're making these like declarative, documents to say, this is how I would like my container to run. And there's a lot of people that would like a local dev loop. They want to be able to kind of launch the container locally, test it locally, maybe not pay for the resources in the cloud if they have it available on their laptop earlier in the dev loop. And so this will let you do that. This will basically let you have ECS launch the containers using your task definition on your laptop. So
and the other things that I have heard from customers is like ECS Anywhere to run containerized workloads from the cloud back to on-premises, right? That's another way. IoT devices as well. Maybe I know that we've got Greengrass. We've talked about that a couple of times in the show. But if you didn't want to use Lambda and you wanted something that was a bit more of a full container system, ECS Anywhere could be made for that, right? So those are kind of the other I guess ways that I've seen people deploy. I still need to dig into the case study side and like what people actually host and what to stretch across from cloud to on-premises or IoT devices or their laptop.
Another good use case would be like if you had a lot of data, like at some like off-site location, and you needed some mechanism to host some compute offsite, but you wanted to remain like standard in your practices, right? Like that's probably the most viable use case for this. Testing at home is great, but the customers really want to run. They need to run some sort of compute on premise or on an edge, some sort of different location, but they want to do it in a standard way, the way they're operating their cloud environments, right?
Yeah. So to be clear, you can run ECS Anywhere on anything that is a Linux machine that has systemd and Docker. And so in this example, we're showing you how to do it on your laptop. And the reason why I'm doing it in Docker, I'll get to at the end, which is basically you can easily clean this all up without kind of making any changes to your laptop. Even if it happened to be a Linux laptop where I'm already running Ubuntu instead of Mac or Windows, as an example, I can just do like a Docker, stop Docker RM on my ECS Anywhere kind of, container, and it'll all go away and be nicely cleaned up. So I'm not messing with kind of deploying the SSM agent and the ECS agent to my local machine if I don't want to. So I'm using this as kind of a way to show you like how to leverage your laptop as an early dev environment. But to the points on other use cases for ECS Anywhere, basically anywhere that you want to run your containers, as long as you have a Linux OS and Docker on it, you can make that happen. So to kind of just show you a little bit about what I mean, with the demo. The first thing that we're going to do is that Docker file. I've already built it using an image called ECS Anywhere Docker and Docker. So this image, like I said, is Amazon Linux, where I've made sure to set up systemd, which is a requirement for what you're going to see in a minute. Other things I'm doing here. So -d says run it in the background. -- privileged. It needs to be in privileged mode to have access to the host in order to do Docker and Docker. I'm giving it a name, which makes some of the subsequent commands easier. And then this port mapping, we're going to get into in a bit more detail. Basically, you may have seen this -p where I do like one port, like 8080 to 8080 or something, but you actually can do a range as well. And why we're doing a range will become interesting in a minute. But I'm basically saying I'd like to map the ports 8080 to 8090, all of them, from the container through to those same ports on my laptop, so that I can open up my browser and preview them on the Windows side. So if we go ahead and run that command, we now have this running container that is doing things like running systemd for us, which we'll need in a second. The next thing that we need to do is do a Docker exec, and we want to do this interactively. And we want to go into the ECS Anywhere container and run bin bash interactively.
Just quickly, Jason, for anybody that happens to be following along, that ECS Anywhere D&D container, that exists locally as a latest because you've gone ahead and you've built that. So that's not published into Docker Hub at the moment.
It isn't. So if we go back to the Git repo, I've taken this Docker file and I've already built it. Maybe I should have done that in front of you, but yeah, I mean the instructions show you how to do it. You do a Docker build of this Docker file, and that's how you get the thing that I just ran. And so to kind of further illustrate the point, we'll cover this again in a minute. This is the laptop's view, where I see that I'm running this ECS Anywhere container. But then inside the container, I can do a Docker PS, and inside the container, the Docker in the Docker, there's no containers running. So that'll be relevant in a minute. So this shell here, this bash, is running within that container, and we'll come back to that in a second. So the next step is basically that we're going to create our ECS cluster and join that Docker and Docker to the cluster. Also, it's worth noting, I've done one other prerequisite step. I've pushed the container that we're going to use as our test to ECR. So you'll see me using this container in a minute to be my example. You'll notice when you create your repository here, if you want to know how I pushed that, we nicely in the console give you the push commands, the commands to log into ECR, to build the container, to tag it appropriately, and to push it. So I've already done these steps in the interest of time, and I pushed, this particular container image is the one that we're going to use as our demo in a minute. But if we go and have
I'm suspecting we're going to see 9cat looking at that. Is that right? Nice.
Pretty much.
Nice.
Yeah, we'll get to that in a second. But yeah, so if you have a look, though, you'll see we have no ECS clusters. So the first step in this process is we want to create an ECS cluster. And we're going to use this cluster only for external things, ECS Anywhere. So we're going to pick this option here for what we want. And we're going to go next step. We'll give it the name ECS Anywhere, and great. Cool. So now we have an ECS cluster. These provision quite quickly. So it should already be kind of done by the time I've refreshed here. Yeah, so for those of you that have provisioned EKS clusters, ECS provisions in like 2 seconds instead of 10, 15 minutes, which is handy. And then the next step is we have to give this ECS Anywhere capacity that we want to run our containers. And in this case, we want to do it on my laptop in that Docker and Docker container. So you click this Register External Instances button. And then there's a couple options here. The defaults are all fine. This key duration, you'll notice in the command we're about to see, there's like a pre-shared key to join it. So this is how long that key will be valid. So we'll go ahead and hit next. And then we have this command. And in this command, you'll notice that it's downloading and running a particular bash script. When we look at this activation ID and activation code, these are the kind of pre-shared keys to get everything going. So we're going to go ahead and click the copy button. And then we're going to come here and we're going to paste that command into our Docker and Docker container. And what this is going to do is basically install 2 things. First, it's going to install the systems manager agent. So the systems manager is used for a few things in ECS Anywhere, but the main one is it negotiates a AWS IAM key I should say AWS IAM assigned kind of credential that gets rotated. So the ECS agent needs to have AWS IAM permission to talk to ECS. And so the main thing Systems Manager is doing for us is facilitating that. Obviously, Systems Manager can do all kinds of other things, and you've long been able to join machines wherever they may be to Systems Manager. ECS Anywhere kind of stands on top of that and leverages Systems Manager for a few things. But now that that's done, if we do a Docker PS, you'll notice that the ECS agent actually runs as a container. And so the ECS agent is here up and running. This allows me to talk to ECS. And if I do a PS in here, you'll notice, I'm running my Docker and Docker container D. I'm running the SSM agent, and then I'm running, the ECS agent via container. So
if SSM's on, does that mean that you get the advantage of like managing in Systems Manager, running commands remotely, doing patching? Yeah, you do.
Yep, you could do all of that with it. Because we're talking about Systems Manager, I'll show you that side of it. So if you Fleet Manager, you'll notice that that script that we ran joined the machine to Systems Manager. So this is that Docker and Docker container on my laptop is now kind of in Systems Manager. And if we go back to this ECS view, I now see that in my ECS Anywhere cluster as well. And as I said, the neat thing about this is, because it's WSL2, it sees my 8 cores, but it also sees of my 32 gig of memory, what's available to it is about 25 gigabit. And so I've got plenty of capacity here on my laptop to run my containers. So if we kind of come back here. We'll leave this view within the Docker and Docker container. And then if we do the Docker PS here again, all I'm seeing on the host system is my Docker and Docker container. Obviously, this is the beauty of kind of the nested Docker. We'll get back to a few of the interesting repercussions of that in a minute. So now that we've got this registered for ECS Anywhere, let's run something on my laptop. The first thing that we have to do whenever we're dealing with ECS is create a task definition to say what we want to do. Obviously, we could do this ourselves in JSON, but if we do it in the console, it'll generate the JSON for us. And so the first question we're asked here when we use the console for this is like, what is the launch type? And in this case, I want it to be external, which is ECS Anywhere. And I say next. We'll give it a name, so we'll call it 9cat. We don't need a role because in this case, 9cat's not calling AWS APIs. But if it was, for example, needing to talk to SQS or S3, those sorts of things, I could actually give it a role that the task and the one or more containers running as part of the task would be using to call the AWS APIs. But in this case, I don't have one, so I'll leave that blank. As far as the memory and the CPU, we need to tell it, in the case of Fargate especially, how much memory and CPU to use. If you're doing Fargate, it actually sizes the VM it runs your task in based on these metrics. It's saying it's optional for the external launch type, so we won't bother with it. And then we have to add our container definition to our task definition because a task can be one or more containers. So we'll call it 9cat. And then as far as the image, we're going to pull that from ECR, and it has this nice image URI thing with a copy button. So I can go ahead and copy that URI, and I can paste it in as the image that I want to run. The port mappings, this is where things get a bit interesting. So traditionally in AWS, I'd want to say 0 for host port, which says pick one at random. And then if it's also managing a load balancer, it could dynamically map the load balancer to the container. In this case, I can't really do that with ECS Anywhere today. So I have to be explicit. I want this particular host port, and I want it to map into this port in the container. Because otherwise, it would pick one at random, and I also need to map that port out to my host. So as you remember, we had that range when we launched our Docker and Docker of the 8080 to 8090. So I can pick any port here in between 8080 and 8090, and it'll work for my purposes. But I'll do this 8080 on the host to 80 in the container as my port mapping. That's all that I need to specify here. The rest of the defaults are fine. It's interesting, it's not letting me do the add button. Why? What else does it want? So I've got my image, container name.
Is it a private repo? It has a star like it's required, just underneath image.
No, this is authentication. Shouldn't need. Interesting. I'm expecting this to have worked here. I'll give it another shot. Okay, maybe it's going to make me list a memory limit, so we'll do 2024. Okay, yeah, it wanted a memory limit.
Yeah.
Which is fine. So we've got our container, within our task definition, and that should be all that we need here. So we can just go create. Now, like I said, what the console was doing was generating the task definition, which is JSON. So if you wanted to have this be a part of a pipeline or something going forward, you can just use the console to help you kind of generate the initial one, and then be inspired, I guess, by the JSON output that the console gives you. But So we've got our task definition now. And let's go ahead and launch that in our cluster. So now we can go to tasks. We can say run task. And we want 9 cats, and that's the revision. That's where we want to run it. Only one of them, and external. And so this should just work. If we go back to here, and we see our 9cat containers running. And as that was port 8080 to 80. If we just in our hosts browser here, go to localhost 8080. So this is basically the browser on my Windows or Mac mapped to the Docker in Docker container, and then the Docker in Docker container is similarly then mapping that port through to the container that ECS just launched. So there's kind of a double natting going on here. And if I wanted to run more of these, I could specify a host port of 8081, 8082, and it will all just kind of similarly map through within that range I specified. So we've got our container running on the laptop, which is great, but I launched that as a run task instead of as a service, which means that if I do this as an example, and I like stop that task, ECS isn't going to restart that for me. So if I go here and then I go back to my cluster, you're going to notice that my task is now stopped. It does report back to ECS that thing is stopped, but it's not going to restart it for me. The thing that restarts tasks, if they go away, fail a health check, all that sort of thing, is an ECS service. So instead of just running the task, let's do a service instead. So I want an external service. It's filling in all the right things, but I have to give it a name. So we'll call it 9cat, and I want one. Actually, I'll show you what happens if we say 2 to this one. So and then that's all we need to do. Create. So now if we go back to the cluster, you'll notice that now we have a service called 9cat, and I'm saying here I want 2. I should only get 1. And if we look at the events, you'll see why. Because we were explicit in our port within the task definition, saying we wanted host port 8080, the first one was able to get host port 8080, and when it tried to launch the second one, it wasn't able to get 8080. So if I had put a 0 there, it would have picked 2 ports at random. But I've had some dramas with then getting that to do the second NAT in the ECS Anywhere double NAT. So this is kind of illustrating the point of why you want to say 1 on your local laptop instead of 2. If I wanted to have 2, what I'd have to do is have a separate task definition and be explicit, that I wanted like another port in the range 8081, 8082, that sort of thing. But that all said, if we go back to this, you'll see that we have our 9cat is running again. So we can kind of refresh this and it'll be there. And this time, if I do a Docker stop and I pick that container, simulating a failure of this container, it should pretty much immediately get relaunched by ECS, because the service is smart enough to know. They said that they wanted one of these running, so let's make sure one of these stays running. So I'll show you that over here. One of the ways to view that would be the service's events. So yeah, it's noticed and it's restarted the task. And if I do a PS here, I see it running again. So that's what the service is doing for you. There's my running a container on my laptop via the ECS service. The nice thing about this Docker and Docker approach, though, is all that stuff that I just did is like super easy to clean up. So all I have to do to clean this up is, if I do a Docker PS, I could do a Docker stop on ECS Anywhere, which is what I named that container. Actually, before we get to cleaning it up, I'll show you how you can leave it around without taking up resources on your laptop and start it when you want. So now, if I look, I don't have ECS Anywhere running, but it's still around. So I did a Docker stop, but I haven't done a Docker RM. If I want to get it going again, I can just do Docker start ECS Anywhere, and it'll start that same container again, and it'll keep all of its same context. It's still part of Systems Manager. It's still part of ECS Anywhere. So that's a way to kind of quickly free up the stuff on my laptop and get it running again when I want it to. So I wanted to go here. And then
Jason, before we go ahead and clean it up, we can run more than one tasks at the same time locally, right? So if we had services that were interacting with each other.
Yep. So what we'll do is the reason why that last one didn't work is that we were explicit about our ports, and that port was already used. So if I wanted to do it again, what I would have to do is this time when I do my port mapping, I'd have to do 8081 to 80. I think that's what else? Oh, image. So we have to copy that again. So we'll go ahead and run this one once it exists. Okay, so we got now
launching. I might just get a comment from Green Knight. So can this work without network access to AWS hosted ECS, or does it require that access back to AWS to effectively run?
It requires access to AWS. It's an outbound HTTPS connection to the SSM and ECS control planes. So all of the management is happening in the cloud, and you need outbound internet access to those public endpoints in the cloud. So we'll pick get 2 here and run. Okay. So now I not only have but 8081, I've got it running again. If I go Docker exec. We'll go back into our container, and if I do a Docker PS here, you'll see that it's running the second 9cat container. That one was fine because I specified a different host port. And then due to the double natting here, where we're doing the whole range, 8080 to 8090, the 8081 was natted through as well. So yeah, I mean that's basically what you get with ECS Anywhere. It's the ability to have to leverage the compute that's on your laptop, as one of the environments that you can manage using the same infrastructure as code and various tooling that you'd be using in the cloud for that level of consistency.
Jason, what would happen if there was a disconnect, like if the internet went down? Does it stop the service? Like what happens?
So it would keep the container running. So basically, the administration ends. So if the container were to die, it wouldn't be healed, but it'll just everything will continue exactly the way it was until the reconnection. The reconnection, it would evaluate what's going on, see that the task is still running the way it expected, and it would leave it alone. And so you can suffer, I would say brief periods of disconnection really without issue. The only thing that you lose the ability to do is launch more containers or have them be healed by the control plane should something go wrong on the remote place you're running the container while that disconnection is in progress.
Yep.
Does that make sense?
Yep, that makes sense. Thanks. And so, what about if I'm running this specific workload on my laptop or on an on-premise location or a different location, and I want access? I want my user to be able to access that. Can we configure the load balancer all the way through, and will that tunnel through?
There's no load balancing integration. So if you look at the things that you can't do with ECS Anywhere today, we actually are pretty explicit about them in the console. and I maybe didn't highlight it when I said external here, but when you do external, there's a place, maybe it's on the service. So we'll go back to, there's three things that don't work: load balancer integration, auto scaling, and network options, because it just leverages whatever the Docker networking setup is on the machine where it runs. So if we were to go to new service, I think is where it is. Okay, so when you say the external launch type, you'll notice here it says, when using external launch type, networking, load balancers, and tag propagation aren't supported. So if I were to try to specify these options, it says, no, I'm not going to do that because you've chosen launch type external. So what you're expected to do, if you were, for example, running ECS Anywhere in your own data center, is you'll have to manually configure some form of load balancer, whether it's Nginx or an F5 or something. And you're going to have to basically have something take the requests from the internet to the machine where they're running and do that port mapping today.
So if that was your laptop and at home, you would just use your router to port forward
Exactly.
port 80 or port 443 or whatever directly to that host machine, which would then double NAT it all the way through that container running the host.
Exactly.
Yeah.
Cool. When it comes to cleaning this up, there's basically two places where that happens. If you were to clean it up on your laptop, the way that you do it is you just do a Docker stop ECS Anywhere, which is what I named that container. And then once we're sure we're not going to want to start it again and keep all that same mapping into the systems manager as well as the ECS cluster, I can do a Docker RM ECS Anywhere. And this basically is Docker just throwing away everything I just did. My laptop is exactly as it was when I started. I then, in order to make it go away in both SSM and ECS, I pick that instance in SSM Fleet Manager, and I say deregister. Once I do that, you'll notice that not only does it go away in Fleet Manager, I think we need to refresh the whole page, and it will eventually disappear from Fleet Manager. And then further to that, if I look at my ECS cluster, you'll notice it no longer has any instances associated with it. So if we go to ECS instances, I guess once it disappears in Fleet Manager, it disappears from here as well. That might take a moment. But yeah, and then basically I just have to do the whole process again. If I want another one, I click this register external instances. I take this command and I paste it into a new container to join it back to SSM Manager and ECS Anywhere.
Nice. We did have a question in the chat around EKS Anywhere, and I know we announced at the same time as ECS Anywhere last year for reInvent. That's still on the horizon at the moment, isn't it? It
is. So there's a beta at the moment, kind of ongoing for EKS Anywhere. And I believe that they may have as many customers giving feedback on that as they need. But if you want to try out EKS Anywhere, ask your account team. They might be able to get you in on the beta, but it's getting pretty close to closing. But basically, the difference between ECS Anywhere and EKS Anywhere is that ECS Anywhere, the control plane is in the cloud, and you're just joining your compute infrastructure, anything that can run Linux to be managed by that cloud ECS. EKS Anywhere runs a whole local Kubernetes control plane. So the database that backs Kubernetes etcd, it's running one of those. It's running the API servers, all that sort of stuff. And so it's much more resource intensive. Going back to the question that was asked earlier, is that if you have a disconnection between EKS Anywhere and the cloud, you have a local control plane that's doing the health checks and the healing. So that it'll deal better with that disconnected state. And the trade-off for that is basically running way more infrastructure locally.
Yep. There's another question here from Hallaloop, and there's actually two questions he asked that I'd like to hear the answer from you. So Is there a way, is there some sort of service discovery when you're running ECS locally? Like how does that work? How do they know that other services are running and how to interact with them?
So it would know about the other things that ECS has launched. So containers that have been are part of the same cluster that were launched on that machine by ECS. So that would exist. Other than that, there really isn't an inbuilt service discovery. You would need to have some mechanism, whether it's DNS or maybe all of the ways that you would traditionally do your own service discovery would work, but there's nothing provided by the service exactly, short of other things that are being managed by ECS Anywhere.
Yep. And the second question that Hello Lupin asks is, and I'm not sure whether he asks this about ECS or EKS Anywhere, but does this support the ARM64? Can we use the Amazon Linux-based images with the ARM images? So we could run that Docker container on my Raspberry Pi.
Or a MacBook M1, right?
Yeah. So yes, I did try it and it works on an M1 Mac. I haven't tried it on the Pi, but I mean, if the M1 Mac is ARM64 as well, so that makes sense. I would go as far as to say if it's a Raspberry Pi, given like the limited resources and stuff there as well, and the fact that it's already Linux, I might be more tempted to just paste that command onto the Pi itself rather than trying to do a Docker and Docker. The reason we're doing Docker and Docker on a Windows or Mac machine is because it's the easiest way to get you a Linux environment in a really clean way on those machines that aren't native Linux. If it's native Linux, the value of the Docker and Docker approach is a bit less. I know, for example, if you take that command, when you click the register external instances button and you paste it onto a Raspberry Pi, it just works.
Yeah. Well, I mean, look, I like to squeeze the performance I can out of small devices, so I'll be trying it anyway. I'm sure some of the audience will as well.
Yeah,
and Hello Lupin says there is an 8 gig version as well of the Pi 4. So I mean, it's a reasonable little machine.
I've got a 4 gig and an 8 gig. I would argue that it's probably going to work. Like I think it's like 1.8 gigahertz times 4 cores. I think we might be surprised. I'd be rooting that the Pi could do it if I was a
ECS Anywhere. Like I said, we have a blog post and some material from our evangelist Nathan Peck, showing all the ways you can kind of integrate with Pis, and so it definitely works. We've got material on that. What I thought was interesting to bring to the table today that I hadn't seen elsewhere was this idea that you invested in some cases an expensive MacBook. Let's just use that, and that's another thing that obviously this allows you to do.
Yep. Green Knight asks another question, and you could probably provide us like a good overview. Is CloudFormation the preferred deployment tool for ECS? So what are you seeing our customers use to deploy onto ECS?
So ECS is the AWS platform, and obviously you can manage ECS using whatever tooling you want to manage AWS with. So the two most common tools I see are CloudFormation and Terraform. It basically is AWS APIs, and then rather than calling them yourself, you usually want to use an infrastructure as code tool. I'd argue CloudFormation is a service to do it, whereas Terraform, unless you're paying for kind of the managed service from HashiCorp, is a tool to do it, where you then have to spend a bit of your own effort kind of getting the tool working and maintaining the tool, whereas that kind of comes like as a service with CloudFormation. But yeah, certainly the way that people generally manage ECS is via CloudFormation. The proviso I would put on that, I guess the asterisk, is that there's two tools that kind of manage CloudFormation for you with an ECS focus. One is a new service we launched called Copilot, and basically that is opinionatedly generating CloudFormation for you to do ECS things with an nice CLI. The other thing, which is almost the opposite end of the extreme, is we have the Cloud Development Kit, which is a way to take normal programming languages like Python, Java, C#, and use that to generate CloudFormation to manage ECS. And there's a lot of high-level patterns that make that easy if you use those classes of CDK. But yeah, those would be the tools I generally see with ECS.
CDK would be the route that I'd go down because it's probably going to make my life a bit easier, and I can work in the programming language I'm comfortable with. The other thing was Terraform did actually, we announced last month, start of June, Terraform actually has full support for ECS Anywhere as well. So not just ECS, right? That's been around for a while, but ECS Anywhere has full support as well. So it's worth pointing out.
Thanks for that Copilot link, Paul. Yeah, Copilot is interesting. We could do a whole session just on Copilot, but basically it's kind of elegant in the way that the Apple ecosystem sometimes is. It has kind of one way to do things, and if you're willing to change what you're doing or build something new in line with the Copilot way of doing it, it'll feel very easy and elegant. Where you run into places where you might choose CDK over Copilot is if you want to do something a little different to what Copilot wants to do. CDK can do anything that CloudFormation could do, whereas with Copilot, kind of the benefit on one side turns into the negative on the other, which is it's being opinionated, which is great if you like the opinion, and if you don't like the opinion, then obviously it's a bit limiting in some respects.
I think Green Knight sort of and summed up what you said by he's used SAM recently. SAM is really great, but when you need to go above and beyond that, you go back to CloudFormation or CDK to do it. So I guess that's the same type of thing. It's an abstraction of the top that's a little more opinionated, but gets you there quicker.
Definitely.
Yeah. Well, that was a really good overview. Now I have a really good understanding. I think that Daily Push has said, and I kept this in the back of my mind, yes, please try. And I'm positive he was referring to, we must try this on a Raspberry Pi and see how that works. I think I can just see Matt already ticking away. I know I'm definitely going to do it.
You know what?
Take that Docker file and run it.
Maybe we don't do the Raspberry Pi 4s, but I've got a couple of the compute modules, not the newest ones, but I've got that cluster of 6 of them linked up. Maybe we create a full cluster running locally on those compute modules. Maybe, yeah.
I think we'll have to try that, and if we get that working, and I'm sure it will, we'll at least just show it next week, and just to show the audience and to prove that it works. I mean, it's just one of those things we want to, because we want to see it. But
great.
Yeah, that was a really awesome overview, Jason, and a ton of good questions coming from the audience. So it's clear that people are interested in these services, and there's probably a lot of us that are interested because we're curious of how it works and how it all fits together. But there's actual real world use cases for those scenarios, because there are instances where workloads have to run closer to the appliance, whatever that might be, and keeping consistent tooling around that is something that's really important. In exactly the same way as the introduction of Lambda containers, Lambda containers provide no real inherent benefit other than, I mean, there's a larger image that you can deploy, but it's consistent tooling, consistent set of tooling all the way through, which helps developer productivity, which I think is really important. So.
Excellent. No, it's been great having you on, Jason. I was going to say we could spend 5 more minutes going through questions, but I just realized we're all going to something back to back. We're getting trained on Cognito. Sometime we might share some of those learnings with everyone, but we're going to jump across to that. So thanks everyone for joining us today. I hope you really liked the session. Call out to Jason if you want him to come back and show you some cool EKS or ECS stuff in the future. I always love having Jason on because he's such a wealth of knowledge in the area. But yeah, thanks everyone for joining us over lunchtime, Australia time, and for everyone that joined internationally, thanks for making the time during your day or evening to join us. I'll catch you all next week. We'll be on the same time. We're on the same time every week. Next week, we're going to have a look at SQS, so quite excited about that. And then we've got some really cool things lined up in the following weeks. So thanks again, everyone, for joining the stream, and I'll catch you all later.
Thanks all. Take care. Reach out with any questions.